So we have a little storyline to follow. The name of this skit is called The Book of Magic. You all can read a little story to go along with it. Right? Get a lot of people are still missing from class, so give them a minute or two to reach. Right, so you have the storyline there, and the book pulls you into this magical world. And of course, your aim is to survive this magical world. All right. Don't worry, guys, we're going to get to the questions just now. Don't worry. Right, so the first part of the game, everyone has to make a choice, right? All right, guys, on the chat, which choice do you make? The red choice or the yellow choice? Let me know on the chat. Whatever you choose, you cannot change it. Right? For those who played this game already, I changed around everything, so don't worry. All right, so the class is mixed. Some people say they'll go with the red choice, the one on top, and some people are, they decide to run. These are the outcomes, right? For those who chose the red, you made the right choice. Add 3 points to your 10 points. And for those who chose the yellow, unfortunately, that's the wrong choice. -2 from those 10 points, right? So keep track of your scores and whatnot, okay? Let's go. So this is the first question that I actually want to do. And this is in most exams, even in Form 3, right? Not even Form 3, right? Even in CXC. For some reason, they always bring a fractions question and they always want you to do it without a calculator. So push aside those calculators. Now, in this question, in this particular question, you will see that we have mixed fractions. Like this one here, this is a mixed fraction. You'll remember this from primary school. Mixed fraction, mixed fraction, mixed fraction. Let me give you some advice. Mixed fractions are the worst. Always work with improper fractions. So the first thing I want everyone to do is convert this to an improper fraction, this to an improper fraction, and this is to an improper fraction. Just in case you can't remember, let me just show you my made-up example here. If I had 5 2/3, this is a mixed fraction. To convert it to an improper, you say 5 multiplied by the underneath number. So 5 by 3 is 15. And then you add the top number. 5 multiplied by 3 is 15. Plus 2 is 17. And then you put back the denominator. So do that for all of these here. Like I said, never, ever, ever, ever work with mixed fractions. They are the worst. So quickly, and let me know when you finish. Obviously, if you want to send the answers on the chat, you can. I'll try to read as much as I can. But that's the first step in any fractions question. Right? Remember, no calculators. Right, and we see a lot of answers coming up on the chat. Once again, only I can see your answers. So this one here, let me put it in brackets quickly. 3 by 7 is 21. 21 plus 2 is 23. So we put 23 on 7. Remember, we put back the denominator plus 1 multiplied by 3 is 3. 3 plus 2 is what? 5. And then we put back the 3 underneath. And I'm putting back all my brackets and everything, huh? Right? So divide. 1 by 7 is 7, plus 1 is 8. So we get 8 over 7. How much people had up to there? Right? Easy so far, right? Easy, easy, easy so far. Now, you all remember something called BODMAS. Remember BODMAS from primary school or even what, Form 1 or whatnot, right? You just always work out the brackets first. So here's what, you want to keep your working very, very, very neat for the examiner. So you could probably say you put the word brackets, right? Remember, working is very, very important. So you put the word brackets to symbolize, hey, I'm going to work out the brackets first. So we put 23 over 7 here, plus 5 over 3. So that's the brackets. You all remember how to add fractions. Well, the easy fractions in any case. Today in the later questions, you're gonna meet some terrible fractions. I consider these to be the easy fractions. So just like in primary school, you would do what? You would find the LCM. Now, the LCM of 7 and 3 is what? 21. 7 into 21 is 3. Take the 3 multiplied by 23. So you'll get 69. 3 into 7 is what? 3 into, tell me, I give the answer there, sorry. 3 into 21 is 7. 21 by 5, sorry, 3 into 21 is 7. 7 by 5 is what? 35. So when we add this up, I'm going to put it over here. Help me out. 69 plus 35. I know we're not supposed to use our calculator, but I know some of you are still going to use a calculator to add 69 and 35. I am too. So I'm cheating a little bit. Sorry about that. How much people got up to there? But that's only what? The brackets part. We are obviously not finished. So it means that when we work out the brackets part only, we get 104 on 21. So I'm running out of space here, so I'm going to go here. So here we have 104 on what? 21. But we still have to what? Divide it by 8 over 7. Now, how would we do this in primary school? I like to use the word here, primary school, because we did this in primary school, and we're so lucky it comes back for high school. Remember in primary school, if you have a divide situation, you write back the first fraction, you don't change anything. Look, I write back the same exact first fraction, but the divide will change to what? Multiply. And then you will do what? Flip the second fraction. But I use the word flip, right? But the real word is not flip, it's reciprocal, which means the underneath goes on top, the top goes on underneath. So you get 7 on what? 8. Before we multiply this out, right? Can we simplify anything here? I think I see something that can be simplified pretty easy. 7 into 7 is what? 1. 7 into 21 is 3. So that could be reduced. What about this? 104 divided by, I think 4 could go into 8. 4 into 8 is 2. And 104 divided by 4 is 26. But that could be reduced even more. In fact, I think 104 could be divided by 8 straight. So let me do that. 8 into 8 is 1. And 8 into 104 is 13. Okay? Great. So we multiply the top by the top, and what's left of the underneath by the underneath. 13 by 1 is 13. 3 by 1 is 3. So our final answer as an improper fraction is 13 over 3. Or if you want to put it back to a mixed fraction, you can get 4 and 1/3, right? Because 4 by 3 is 12, remainder 1. Now, different teachers are different. Some teachers have no problems with improper fractions. Like me, I love improper fractions. But some teachers might want to what? See the answer as what? A mixed. So you know what I just do as a safety feature in my exams? I just write both. I'll write the improper and I'll write the mixed. That way, nobody could complain. Right. Now, like I said, you're already supposed to show all the steps in the exam. And you have to like pretend you're not using a calculator, right? I know once in the exam, you have a calculator next to you. You're going to use it to double check certain things. But this will give you full marks in the exam. How would you all rate this question? Easy, medium, or hard? Don't worry, you're going to get our next practice question, right? The aim is to make the questions ridiculously hard to prepare for any scenario. Easy stuff, right? Easy. So I've given everyone a 20 seconds to take down anything they want to take down. And, we will take it we'll move on. Let's go, right? And don't worry if you didn't get to take down everything. The video will be what? It is being recorded, and I will send it on the chat and thing and whatnot after, right? Let's go. Look at this one here. So it's a little bit intimidating, but I guarantee you, if you turn everybody who's a mixed fraction into an improper fraction, it will seem a little bit easier. So do that for me first now. All the mixed fractions, right? Like this one and this one, converted to what? Oh, this one too. Converted to improper fractions. And then we will start the question. So take 10 seconds for that. Two by 3 is 6, plus 1 is 7. So we have 7 on 3. Well, 3/7 is, we don't need to convert him to anything. Divided by, right? I'm going to use a different color for the underneath. So the underneath thing, 2 by 3 is 6 plus 1 is 7 again. So 7 on 3. Multiply 1 by 7 is 7. 7 plus 3 is 10. So you get 10 on what? 7. Now look at this. The top and the underneath have slightly different functions. The top is addition and the underneath is multiplication. Now, under stress in the exam, I've seen this already. People will mistake the multiplication for an addition. Because the top is an addition, your brain will say, right, the underneath resembles an addition, and it will create the image that it is an addition. Now, here's what I usually do in the exam. So I have proper working. I will put my little squiggly brackets here, and I'll call here top. I will physically write that in the exam. And underneath here, I'll write bottom or underneath. UND for underneath. I always write underneath, right? So when I go to my working now, I put top. So the examiner knows, hey, he's working out the top. So my working is easy to follow. So I put 7 on 3 plus 3 on 7. Find the LCM as usual, right? LCM is 21. But that's a horrible color I used there. Let me get a better color. But there's not much colors that show good on pink or red. 3 into 21 is what? 7. 7 multiplied by 7 is 49. Plus 7 into 21 is 3. 3 by 3 is 9. So 49 plus 9 is 58 divided by 21. This is what I got when I worked out what? The top, right? But what about the underneath part now? Let me just draw a little dash line here, right? I'll put U and D here. So the examiner knows I'm working out the underneath now, right? We could simplify and whatnot afterwards. We could get to that afterwards. Now the underneath is a multiply. It's 7 on 3 multiplied by 10 on 7. Now immediately here, and we see something that could cancel out real easy. Won't this 7 cancel out with that 7? So what you'll be left with, number, 7 to 7 is 1, right? So how you multiply? 1 by 10 is what? 10. And 1 by 3 is 3. So for the underneath portion, we just get what? 10 on 3. But is the question finished there? By working out the top separately and working out the underneath separately, is the question finished? The answer is obviously no. Because we were supposed to take the final top answer and look at big divide sign here and divide it by this. Now I'm going to write it a little bit different. The top part worked out to be 58 on 21. Then we're supposed to write divide, but instead of putting a divide sign like this, couldn't I just write it like this, like in primary school? Divided by the underneath, which is 10 on what? 3. I think it would be more useful if we wrote it like this, if we wrote it horizontal rather than vertical. Because when we write it like this, we know the divide will change to a multiply, and whatever comes after, we flip it. In other words, the reciprocal. Right. Can anything, do you think you all can multiply that out or, reduce anything before multiplying it? I see something that could cancel out there for sure. Right? I think I seen something. A couple things, in fact. Yeah, 3 into 3 is 1. 3 into 21 is 7. And then the 2's. 2 into 10 is 5. 2 into 58 is 29. So we divide both of these here by 2 or reduce them by 2. We almost finished. What's left of the top? Multiplied by the top here. 21 multiplied by 1 is 29. 7 by 5 is 35. This is my final answer. So for term test or for CXC, I hope you all really get this, right? I hope you all really, really get a question like this. It's easy, easy marks. 20 seconds as usual. Take down what you need to take down, and we're going to move on. All right, so we have a little cut scene here. All right, so let's see what's going on here. So apparently in this strange land, you take a little walk, and there's a little treasure. It's a little, sorry, it's ending, sorry, around 8 o'clock, right? So there's a little treasure chest here, and you try to get to the treasure chest, but a ghost appears. Which pumpkin are you all going to choose? The first pumpkin, pumpkin number 1, pumpkin number 2, or pumpkin number 3? You can only choose one. Obviously, one of them is the correct one to choose, and the other two is going to make something bad happen to you. So get ready to update those score sheets. All right, let's see which one is the correct one. Right, if you chose pumpkin 1, the pumpkin explodes and releases a toxic gas. So the red choice, the first pumpkin, is the bad choice. The good one was the green one, right? The third one was the pumpkin of peace, whatever that is. And she lets you pass to collect the treasure chest. Update your score sheets. The first pumpkin, -3. The blue pumpkin, also a bad-ish choice, -1. The green pumpkin, the third one, add 4. Remember, we started off with 10 points today, right? We started off with 10 points. Sorry, I have a little cough today, guys. So you hear me coughing a little bit. Let's move on. Let's move on. Now, this is something here that causes a lot of problems, right? Before we start the question, right? The one that normally causes problems is the middle one here. Significant figures. Now, I'm going to give it a shortcut. This is just a revision class, right? I'm just going to give it a shortcut on how to do significant figures. You see, when they give you a significant figure question, they will ask you to round it off to like 1 significant figure or 2 significant figure. So let me do my own examples first. Let's say the question wants you to do it to 2 sig fig, right? That means significant figures. Now, it's either the number they're giving you is going to be greater than 1 or going to be smaller than 1. My first example, the value is going to be more than 1. So let me make up something. 682.53. And they ask you to convert that to 2 significant figures. Now, a lot of people mix up significant figures with decimal places. Decimal places come after the decimal point. For example, this is the first decimal place, and this is the second decimal place. You see, for decimal places, you start counting after the decimal point. But significant figures is not that. You see when a number is greater than 1, and this number clearly is greater than 1, is 682. Significant figures, you start to count from the very, very first number. So this is the first significant figure. This one is the second. This one is the third. And of course, this will be the fourth, and this will be the fifth, right? How much significant figures do we want in this made-up question? I just made this one up on the spot. We only want 2 significant figures. So that means we only want number 1 and number 2. Do we really care about the rest of them? The answer is no. We really, really, really do not care about the rest of them. But if we only want 2 significant figures, you see, after the second one would be the third one. We have to ask, is that number greater, 5 or greater? And remember, if it's 5 or greater, we're supposed to add 1 to the 8. So do we have to add 1 to the 8 today? Do we have to add 1? The answer is no, because 2 is not 5 or greater. So we just put it as 6. We do not have to add 1 to the 8, and everybody else after, we don't really care about them. So everybody else after, we just put a 0. So everybody else after turns to a 0. So the 2 changes to a 0, you put the decimal, the 5 and the 3 also change to a 0. Now, some people will argue and say, hey, do we really have to put the 2 zeros after the decimal? Well, the truth is no, because 680.00 is the same thing as 680. The 0.00 have what? No value. But actually, no, it's probably a good idea to leave it out in this case, right? Because it doesn't look cool, right? It looks very, very unmathematical. But if you leave it, it's still correct. Now, remember, this is when the value is what? More than 1. Let's try something. Are we going to go, let's say, 3 significant figures, but the example is going to be less than 1. So let's choose a value that's very, 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 very small. Way greater, so way smaller than 1. 0.0005, let's call it 2389. That value is clearly what? Less than 1. Now, whenever the value is less than 1, and they ask you for 3 significant figures. Let me just they ask you for 3 significant figures. Do not start counting from the very first number. Remember, when the number is greater than 1, we just start to count from the very first number. But when it's 0.0000 something, you see the first, you just ignore all the zeros. So you're ignoring this 0, and this 0. You just actually start to count from the very first number that is not 0. Make sure you understand that real people just mix up that. So for this question, we're going to start to count from the 5. We just ignore all the other zeros. How much significant figures we want? 3. So he's the first. He is the second. He is the third. And we really don't care about anybody else. We don't care about the 4th. We don't care about the 5th. But we still have to ask if after the 3rd, if he is 5 or more. That will determine whether we're going to add 1 to the 3 or not. So do we have to add 1 to the 3 today? What do you guys think? We have to add 1 to the 3? The answer is yes. So It's going to be 0.0052. We have to add what here? 1. So we're going to get 4. Now, the rest of the zeros, the rest of the numbers are going to change to zeros. But remember, you don't already have to put the zeros here because these two zeros don't really change the value of the question, right? Right, so, and we're adding 1 to the 3 because the 8 is 5 or more, just like when you're rounding off in primary school. If the number is 5 or more, you always add 1, right? Great. Right, so that's my little revision there on how to do significant figures. I'm going to leave this here, and I'm going to give you all 5 minutes to do A and B. All right? Take 5 minutes. I don't think anybody's going to have any problems with rounding off things to the nearest number. Decimal places is pretty easy. And for part B, you will need your calculator. You will need your calculator. Good luck. Send your answers on the chat. Whole number. Now, let's get it here. A part 1. Remember, it's 64.498. The nearest whole number is either 64 or 65, right? But remember, if this number was 5 or more, we would have to add 1 to this. But this number is what? Less than 5. So we don't have to add 1 here. So the answer for number 1, I would put it as 64. Right? It comes like you have $64.49 or something like that, right? And I ask you to round it off to the nearest what? Whole number, right? So I will go with 64. Right. The second one is what we just practiced. The significant figure. So we write back the number here. 64.498. They ask us for how much? 3 significant figures. And this number is clearly what? More than 1. Yeah, that's 64, greater than 1. So we're looking at this as our template or example to help us out over here. 3 significant figures. We start to count from the very first number. 1, 2, and 3. But since we only want the first 3, we at least have to look at the 4th number and ask ourselves, hey, is that value 5 or more? And the answer is yes, 9 is greater than 5 by a large margin. So do we have to add 1 to the first 4? Yes, we do. So it will be 64.5, right? Remember, the rest of the numbers, you can replace it with 0, but it doesn't look cool, so you can leave it out, right? Just put 64.5, okay? To round it off to 2 decimal places, I think this one has a small trick in it. Let me write back this. You have 64.498. Now remember, decimal places is the one I like because decimal places is you literally start to count after the decimal place. And we only want 2. 1, 2. Do we need the 8? No, but the 8 is greater than 5. Once it's 5 or greater, we add 1. But we have a little problem. When we add 1 to 9, how much we're going to get? 10. And because we get 10, that extra 1 from the 10 goes over to this 4. So we end up adding 1 to the 4 also. So we get 64.50. This one, you have to put the 0, because if we leave out the 0, it will be 1 decimal place. They clearly said 2 decimal places. So you have to put the 0. If you leave out the 0, you will get it wrong in the exam. Okay? So a lot of people said the answer for that one. Right. How much people finish with part B? Or you need some more time with part B? Probably a minute or half a minute. All right, so a lot of people said they still need to do part B. Now you're going to need your calculator. Find the square root of 13. On your calculator, press square root and 13, right? I'm going to have to erase everything on the screen in a little while, right? So take down what you need to take down, and we'll move on to the next question. Well, for part B, we need to find the square root of 13 first. Now, believe me, right? When you find the square root of 13, it's not going to look pretty on your calculator. So when you type in square root of 13, for those who don't have the calculator or cannot find the square root button, or they bought one without a square root button, this is what you would see. The square root of 13, that's the square root of 13 is something, it's a crazy number like this. 3.6055512. It goes on and on and on, right? But the instructions is this. They want you to do what? Round it off to 3 significant figures. Now, 3 point something is definitely greater than 1, right? Everyone agrees with that. So when it comes to significant figures, we start to count from the very, very first number. And we only care about the first 3 because those are the instructions. We care about, this is number 1, this is number 2, and this is the third significant figure. Everybody else after that dash line, we don't care about it. But we at least have to ask the first number after the dash line, the fourth significant figure, is he 5 or more? Remember, if it's 5 or more, you have to add 1. So we have to add 1 to the 0. So the value would be 3.61. That would be the answer. Now, the next part, right? The reciprocal of 13. A lot of people didn't know what the reciprocal is, right? Reciprocal just means throw the number underneath a 1. That's all it means, right? So the reciprocal of 13 is 1 over 13. That's all reciprocal means. If they give you a whole number, throw it underneath a 1. When you take 1 and divide it by 13, you're not going to get a pretty number. 1 divided by 13. How much people see in this on the calculator? 0.07692. It goes on for a little while. How much people saw that? Don't take my word for it. I want you to get involved in the question. Type it in, see it for yourself. Watching somebody do maths is the worst thing you could do. Get involved in the question. Right. Now, is this number less than 1? The number is less than 1, right? 0.067 is clearly less than 1. So remember, when the number is less than 1 and it's significant figures, do not start to count from the very first number. You don't call him 1 and him 2 and him 3. Nope. You skip all the zeros until you've reached the very first non-zero number. So he's our first significant figure, our second, and our third. Everything after that dash line, we really don't care about it too much, but we bend our head through the fence and ask, hey, are you 5 or more? And the number 2 replies, nope, I am number 2. So do we have to add 1 to the 9? No, right? The answer is no. So it's 0.076. And we have to add, do not add 1 over here. So you will get, leave it as 9. Okay? Right. Standard form. Now, standard form is very, very easy to mix up with significant figures. Put away your calculators. You cannot use a calculator for this one. let me do a little bit of revision here, right? Standard form is when you try to express a number as multiplied by 10 to the power something. So let me just do some quick revision here. Whenever you move the decimal point, this is supposed to move to the decimal point, right? When you move it to the left, right, it goes up by +1. The value increases by 1. So that's what +1 means. Don't worry, you're probably scratching your head and wondering what they're talking about. But when you see the example, everything would fall into place. If I take the decimal point and I move it the other way to the right, for every jump that you make, the value decreases by 1. It goes down by 1. And for standard form, the number always has to be in between what? 1 and 10, right? So I'll just put in a little note here. Don't worry, all is going to fall into place here. Number has to be between 1 and 10. All right, so for those of you who don't have those notes, right, I'm leaving it on the screen there. Let's move to a question here. 679.35. So let's say one day I played the lottery and I won $679.35. And you want me to express that in standard form. First of all, ask yourself, is this number between 1 and 10? Obviously not. 679 is greater than 10. But to make that number be in between 1 and 10, the decimal point, and we can move it over here. If we move it in between the 6 and the 7, won't it be 6.7 something? So then the number would be in between 1 and 10. So take the decimal and how much times it have to jump. It jumping from here. 1 jump, 2 jump. It hopping over the numbers until it reaches the correct place. Did we just move it to the left or did we move it to the right? What did we do? We moved it to the left. So that means it has to do something with add 1. So 1. So in other words, when it moved this way, the value gets bigger. I'm talking about this. It hopped 2 places to the right. So check this out. This is how our final answer would look. 6.7935. Remember, the decimal point no longer lives here. He lives here now. And you always put multiply by 10. And since we move it 2 places to the left, it's +2. You don't have to write the positive sign here. You can just put 2. So when we move it to the left, the number over the 10 will usually be positive. It +1, and then we add 1 more, 2. Let me do our next example, right? For those who didn't catch it the first run. 8, let's say I play another lottery, and I win this amount of money, right? So I win this amount of money. I'm not going to try to pronounce that number right now. That's a lot of money, right? And when people hear I win the money, all of a sudden I start to get text messages about how they are my best friends and I should come line with them, right? But is this number between 1 and 10? No, this number is clearly bigger than 10. So I will have to move this decimal place how much? 1, 2, 3, 4. So that it's in between the 8 and the 7. When it's between the 8 and the 7, it's 8.7 something. So that number is what? Between 1 and 10. So I put 8.757628 multiply by 10 to the how much? How much times did it hop to the right? 1, 2, 3, 4. So you put +4 there. Now, these questions are easy. But what about if the number was smaller than 1? Or all of these examples I did, the number was what? Greater than 1. Greater than 10, sorry. So let me put a very, very small number now. 0.00062 5. So we're going to pretend you guys played a lottery, and this is the amount of money you won. Is that plenty money? Obviously not, right? That's not even 1 cent. That's less than what? 1 cent. So to get this number to be in between 1 and 10, we have to move the decimal point here between the 6 and the 2. So that means we have to take the decimal point here and move it 1, 2, 3, 4. It has to go in between the 6 and the 2. So it will be 6. Oh, it's a horrible color there. It will be 6.25. You don't have to put all the zeros in this case here, right? And since we're moving it to the right, the decimal point is visiting to the right. It moved 4 places, but we don't put positive 4. When it moved to the right, it has to be what? Negative. So in other words, when the decimal point goes to the right, the value over the 10 gets smaller. If you're moving it to the left, the value over the 10 becomes more positive. It gets what? Larger. But this question is a little bit different from this. This alone, that what I just showed you, can't make you figure out that question. Take down everything on the screen if you need to, and then I'm going to show you what you need to get this out without a calculator. All right? There's 2 things I have to show you. Let me know when you're ready to move on. All right? This is a real tricky question to do without a calculator. Let's say I have 723.48 multiplied by 10 to the power 5. Is this number in standard form? Now, you're seeing I multiply by 10 to the power something, but is it in standard form? Is that number in standard form? The answer is no. I mean, it looks like it is in standard form. It looks like that because you're seeing I multiply by 10 to the power something. But for it to be in standard form, doesn't the number have to be in between 1 and 10? Is 723 between 1 and 10? The answer is no. It's like somebody was trying to put this in standard form, but shut down midway and didn't bother to complete the question. For it to be in standard form, let me get a different color here. That decimal point has to be here. So it's over here, and we have a 5 here already. So how much spaces does it need to complete this journey? It has to go 1, 2 more. So it will be 7.2348. Now, this number is in between 1 and 10. But what are we going to do with this 5? Remember, when you move to the left, the number over the 10 increases by 1. So it was already 5, and we move it how much? 1, 2. So that means it would be 7 now. The 5 would increase by how much? 2. Everybody with me so far? Let me give you another one so you can compare it. I'm going to do 2 questions. One's going to have a trick. This one here is not going to have a trick. If I have 85.13 multiplied by 10 to the power, let me call it 23. Just say it. Is this in standard form? No, because this 85 is not in between 1 and 10. For it to be between 1 and 10, we have to what? Move it between the 8 and the 5. So to complete its journey, the decimal point has to jump 1 final place to the left. So you get 8.513. And what would the number over the 23 turn to? What would the number over the 23 turn to? We can't leave it as right. Remember, it was 23 at the beginning, and then we move it 1 place to the left. For every jump to the left, it will increase by 1. So it went from 23 to what? 24. That's your final answer. Let me try one now with a trick in it. Let me see. Let me say we have 2253.17 multiplied by 10 to the power. Let me call it -2. What would be the answer for that one if we were to put it in standard form? Notice you start off with a negative power over the 10. Let's see what you guys come up with. Okay. Right. Now, this number here is not in between 1 and 10. The decimal point has to go here. So it's over here, so it has to jump 1, 2 to the left. So we have 2.5317. But this number here, this power over the 10, it's supposed to increase by how much? Isn't it supposed to increase by 2? Now, right now it's -2, right? How much is -2 plus 2? Remember, this number is supposed to increase by 2. We're moving it to the left, so we have to increase it. How much is -2 plus 2? No one's supposed to get this wrong. No, guys, -2 plus 2 is 0, right? This is why I had asked everyone to make sure and review the 2 videos on positive and negative numbers, how to add them. -2 plus 2 is 0. Leave it like that. I know, for those who know indices, 10 to the power 0 is 1. I know that. But leave it as 10 to the power 0. So I try to trick you there. Right? Now, I'm not going to be able to do every single example here. I'm just doing what we need to do in order to get out this question. Right. So I'm going to erase the top here so I can, like I say, discuss something with regards to what? Regards to the indices, right? No, you have to put the 0. 10 to the, a lot of people, guys, 10 to the power 0, is it the same thing as 10? What do you think? Is 10 to the power 0 the same thing as 10? The answer is no. Whenever you have a number without a power, the power is automatically 1. So if you put 10 alone and you leave out the power here, you are assuming that it's 10 to the power 1. No, you have to put the 10 to the power 0. 10 to the power 0 is different from 10. Right. Right. So actually, there's a very easy way to get out of this question. I'm now realizing that I'm just trying to figure out how we would do this question if we did not have what? A calculator. Now, here's what? A little bit of indices. All right? A little bit of indices. If you have 5 to the power 3 multiplied by 5 to the power 2, what do you all remember? When the bases are the same, you can add the powers, right? So 3 plus 2 is what? 5. For example, if I have 7 to the power 6 multiplied by 7 to the power 8. Once the bases are the same and it's a multiply, you add the powers. 6 plus 8 is what? 6 plus 8 is, oh Lord, 14. Try a trick one for me. 7 to the power 5 multiplied by 7 to the power 8. Sorry, minus 8. I'll write it back better. 7 to the power 5 multiplied by 7 to the power minus 8. The bases are the same. Both of them have what? A 7. Right? And multiply means to add the powers. So you're going to end up with 7 How much is 5 plus minus 8? Remember, we have to add the powers. It just so happens the second power is minus 8. A plus and a minus is what? A minus. So you're going to end up with 7 to the power minus 3. Because 5 minus 8 is minus 3. Right. All right, so let's move on to this question now, right? We're going to put everything together. Everything together. When you're multiplying, if I have 4 numbers to multiply, 2 by 4 by 1 by 3. Did you all know that when you're multiplying, you can multiply any pair? Do you really have to multiply the 2 by the 4 first? No, you don't have to do that. You can multiply the 2 and the 1 first. 2 by 1 is what? 2. And then multiply the 4 and the 3 to get what? 12. And then you say 2 by 12 is what? 24. Well, when you're multiplying, you don't have to multiply in order. You can choose any two, multiply them. Where am I going with that? If I have 4.2 multiplied by 10 to the power 4, that is this guy here, multiply by 5 multiplied by 10 to the power minus 3. Do I really have to multiply the 4.2 by 10 to the power 4 first? No, right? Remember, we're pretending we don't have a calculator here, right? Couldn't I just multiply 4.2 by the 5 first? You all can help me out there. How much is 4.2 multiplied by 5? You're not supposed to use a calculator. I know you're going to cheat and use a calculator, but let me pretend. 4.2 by 5. 4.2 by 5. I get in 21. Right, so I get 21 here. And now I'm going to multiply these two. When I multiply 10 to the power 4, multiply by 10 to the power 3, and the base is the same, and you have a 10 here and a 10 here, what do you have to do with the powers? And you have to add the powers? Because when the bases are the same and it's a multiply, you're allowed to add the powers. How much is 4 plus minus 3? A plus and a minus is a minus, right? You're going to get 1. So we just did part 1 here, right? That's the value there, right? And in case you didn't know, 10 to the power 1 is 10. 10 by 21 is what? 210, right? But hear me out. For part 2, they want you to write this in standard form. Is this in standard form right now? The 21 multiplied by 10 to the power 1. Is that in standard form? The answer is no, because 21 is greater. 21 is greater than 10. So we all know it have an invisible decimal point here because 21 is 21.0000. So it have a decimal point here. Don't we have to move it one place to the left? So it's in between the 2 and the 1. If we do that, we will get 2.1. And when we move things to the left, the power increases by 1. So what would be the final power here? What would be the final power there? 2, correct, because it was 1 and we move it one place to the left. So we have to increase it by 1. Right? Right. So this is the way to do it without the calculator. And of course, it all depends on what your teacher says to do in the exam. I know some people would have just said 21 multiplied by 10 to the power 1, like how you know anything to the power 1 is itself. So we get 210. The decimal point is here, so you can just move it 1, 2 places to the left. You will end up with 10 to the power 2 anyway. Either way is going to give you the same answer. All right. Take down what you need to take down. We're going to move on. You're going to realize when I'm explaining topics, I use it as an excuse to explain other topics as we go along, right? But that is what revision is about, right? So when I talking about one topic, you'll see me like how we were starting with standard form and decimal, and then I went to indices. I have to use it as an excuse to talk about other topics. That's the only way we're going to get a total revision to prepare you for the exam. All right, so you all remember that treasure chest that was behind the ghost? We finally approach it. But when we approach it, the sky and the scenery changes. There's a little treasure chest there. But the treasure chest changes into something. It changes into a snake. So it was an illusion to lure us into the you know, to sorry about the cough again. All right, so let's see the choices we have to make here. What you all want to do? Throw a rock at the snake, run up and hide in the vines of the ark up here, or you want to jump in that stream there and see where it takes you. Let me know. Red, blue, or green? Which option? You can just call the color. Red, blue, or green? All right, let's see who has it right. And these are the outcomes. The correct one was the green one, but you can read the red, you can read the blue, just to see what you could have ended up in, what mess you could have ended up in. All right, so the correct thing to do was jump into that stream and let it wash you away. Hopefully something good will come out of it. Let's go. Update your score sheets. All right, so this one here, you're gonna have to use your calculator. Everyone should get through this one by now. We did enough practice in previous questions. So use your calculator and work out this. Now, when you're typing in this on your calculator, make sure and put your brackets there. This one is testing if you know how to use your brackets properly. Good luck and feel free to send all your answers across. When you're typing this exactly as it is on your calculator for part one, right? Remember, you have to put the brackets, you have to put the squared. This is a divide here, right? You will get 125.315. That's the exact value, right? So good luck with two significant figures and whatnot, right? Right, that is gears enough to work it out. Oh, for part two, they want how much significant figures? Two significant figures. So this number is clearly larger than one. So with significant figures, we start to count from the very first value. 1, 2, and they said they want the first two. We really don't care about anybody after that, but we push our head through the fence and say, hey, you're on number 5. If it's 5 or more, we have to add 1 to Mr. 2. So you get 1, 3, and then everybody else what changes to what? Zeros. Everyone after the fence. Now, like I said, after the fence, like that, after the decimal, you'd already have to put these. Leave it as 1 to 10. You don't even have to put the decimal point. 130 is what I would put for my final answer in the exam. For part 3, this one is pretty easy. The number has to be in between 1 and 10. 125 is clearly more than 10. It has to jump how much? 1, 2. So it falls in between the 1 and the 2. So you get 1.25315 multiplied by 10 to the power positive 2. Remember, when it goes to the left, the number above that 10 is going to increase by 1. So it went from 0 to 1 to 2. How much people got all 3 correct? Right? Based on the answers, I think most people got all 3 correct. Let's go. All right. Right. So everyone take down this phone. This one here, you want to make P the subject. So you want to get P on one side and everyone else on the other side. Now, I know some people never did the basics in this kind of question, and it's a long build up to reach this level of question, but I'll try my best, right? The whole idea is this. And for those who did the videos, I think you all remembered something, cross multiplication. How much of you all remember that from the videos that you were supposed to watch or from my normal math class? Something called cross division. Right. Now, remember, cross division is this, right? Like if I have x over 2 is equal to 3 over 5. You take the top from on this side and multiply by the underneath on this side, right? That's a basic example. X by 5 is 5x. And then you put your equal sign and you multiply the 3 by the 2, which is 6. Simple, simple, simple stuff. That's just cross multiplication. Now tell me something. Let's put this an easier way. If I had x on 3 is equal to 4 on 5, that's easy to cross multiply. But if I had a square root sign on top here, and the square root sign only belongs to the 4, could I still cross multiply? Well, what do you guys think? Is it okay to still cross multiply? The answer is yes, yes. I guess based on my tone, you probably thought it was no, right? But it's still, this x could be multiplied by the 5. So you get 5x. Now, when you cross multiply this, it's square root of 4 by 3. Now, it's not going to look too pretty. It's just going to be 3 multiplied by the square root of 4. I know you could square root 4 and get 2 and say 2 by 3 is 6. But if this number was a crazier number, let me say this was 7. You can't square root 7, so you would say what? Square root of 7 multiplied by 3. And we're pretending we don't have a calculator. Now in maths, if I have this now, look at this difference. You have a big square root sign here, and the square root sign is over the 7 and the 5. Can you cross multiply now? And the answer would be no, because this square root sign is blocking everybody here. He's blocking the entire fraction. He is like a force field, you know, like in those Star Wars movie or Star Trek movie, a force field. So when he tried to cross multiply, the x hits the force field, boop, 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 and the same thing for the 3 and the 7. So no cross multiplication can take place until you get rid of that square root sign, that force field. Now in maths, do you all remember this? Like if you have a positive sign and you throw across a positive sign, you just get the opposite, right? Positive is changed what to negative. You take a minus sign, throw it across an equal sign, it becomes the opposite. You take a multiply, you throw it across, you get a divide. And that's a general rule. When you throw something across, it becomes the opposite. So if I have a squared, when I throw across a squared, isn't the opposite of a square root? And similarly, If I have a square root and I throw it across, it becomes what? A square. The moral of the story is when you throw something across an equal sign, it becomes the opposite. So where am I going with this? Right? I'm going to take off this. We need to get rid of that square root sign. We have to. So why not just throw him across? But when you throw across a square root, you get what? Squared. How much items we have waiting here? 2. We have an x and we have a 3. Who is going to get squared? Is it the x who is going to get squared? Or is it the 3 who is going to get squared? Because we just said when we throw across a square root, it becomes the opposite. And the opposite of a square root, is a squared. But if it was like this, if it was x is equal to the square root of 7, and we throw across the square root and it only had one item here, the one item would be squared, right? Somebody said the correct thing. You have 2 things waiting here. When you throw across that square root, both of them, right? Both of them get squared. But how do you write that? You write up what? Brackets like this, and you put a square. You see, when you write it like this, it means everybody here gets what? Squared. Both of them. And this means the x gets squared and the 3 gets squared at the same time. So you can write it like this now. The x gets squared, so here's x squared. And the 3 also gets squared. But we can do that in our head. 3 squared is what? 9. Can we cross multiply now if we wanted to? What do you guys think? Can we cross multiply now? Is there any force fields here now blocking us? What do you all think? Can cross multiplication take place? Yes or no? Come guys, send answers in the chat. Come on. The answer is yes. There's no force field here. You can simply cross multiply, right? 9, I can't remember how much that. I think that's 63. And then x squared by 5 is 5x squared, right? The point is, if there's a big square root sign, get rid of the square root sign first. Let's try this here. I want to rewrite this question. Remember, actually no. Can we cross multiply right now? Because we want to make who the subject? P. So I'm going to write it back here. R is equal to the square root of 4 plus 3p squared. And this is the letter S here. I'm going to write it like a S. Now, even if we assume R is R on 1, because R is the same thing as R on 1, we cannot cross multiply because of this big square root sign, that force field. So, shouldn't we throw across the square root first? You think you all could do that step for me? Get rid of that big force field. And remember, R is the same thing as R on 1. Just like how 7 is the same thing as 7 on 1. Dividing something by 1 doesn't make it any different. Right? I know you're not going to be able to type out the answer on the chat. But when you throw across the square root, both things here are going to get what? Squared. Both of them at the same time. So the R gets squared. So R squared is just R squared. 1 squared is still 1, right? Number 1 squared is still 1. So you can just leave it as what? 1. And now we have gotten rid of the square root sign. Can we cross multiply now? Is it okay to cross multiply? The answer would be yes. Now, I think I gave you all some advice when it comes to cross multiplication. If we are trying to make P the subject of the formula, look at here, it's in the instructions of the question. Remember, we have 2 diagonals here. We have to multiply, oh, that's a horrible color. We have the yellow diagonal to cross multiply, and we also have the red diagonal to cross multiply. Now, if you're trying to solve for the letter P or make P the subject, always cross multiply that diagonal first. Always, it will make life easy. So 4 plus 3p squared multiplied by 1. Anything by 1 is itself. So you get 4 plus 3p squared. You put your equal sign. And then you cross multiply the other diagonal. R squared by S is just R squared S or SR squared. Any way you want to write it, the S could come first. I want you all to solve for P now. Get P on one side and everybody else on the other side. See if you can remember who is here, who is the zombies. Now might need any video I gave you all. Who is the zombies? Who is the pet? Who is the good person, and so forth and whatnot. So take it from there, guys. Solve for P. And remember, this 4 here, he is really positive 4. Put in the positive. It will make life easy. Good luck. Right. So we throw in across the positive 4 first. Remember, we're trying to solve for the letter P. So P come like the good person and the 3 come like your pet. Right? I know you have a squared here, but we'll see about that. This 4 come like the zombie. We throw him across. So we get positive 3p squared is equal to r squared s. Throw across positive 4, we get minus 4. Now we can't simplify this, right? Next on the list, I think you need to throw across the 3. Now remember, I know this is positive 3, but when you have a number and a letter touching, it's a secret what? Multiply. So I think I mentioned this already. When you throw across a multiply, you get a divide. But everybody here gets divided by the positive 3. So you can put a big divide sign here and divide everyone by positive 3. Now, when you throw across a multiply, yes, you get a divide, but the sign of whatever goes underneath remains the same. I remember saying that over and over and over, right? Now we just have one last person to throw across. The squared. Remember, we want to make who the subject? P. So when you throw across squared, you're going to get what? Square root. But the entire expression here, waiting, the entire thing gets square rooted. So you have to draw one giant square root sign here. And that's the final answer. P is equal to the square root of r squared s minus 4 divided by positive 3. I know some of you will just leave out the positive sign. That is fine in your final answer. Right? So we're going to try to make it to 7:30 today or close to 7:30. All right? Let's move on. Let's see what's next. Oh. All right, so remember you jump across the stream or something like that, right? So apparently it led you to a waterfall over here, right? Led you to a waterfall. That's the name of this native. I don't know what I was thinking. So you are hurt and Baga Rabua decides to do what? Take you to her tribe. So what do you plan to do? Red, blue, or green? You want to slash at her with a sharp rock that you found on the riverbank, accept her help, or extend your hand and then try to throw her in the river when she grabs it. What? You all are really trusting people. You're just gonna accept her help. Suppose she's lying to you. All right, let's see what's the correct answer. The blue one was the correct one. Right? All right, so y'all know what to do if you ever fall off a waterfall on a stream. Answer I never taught you. Right. Right, so I want you all to try this question here. It's a cross multiplication question, right? And I want you to try to make y the subject. I'll give you a hint. X is the same thing as x on 1. So you could change this to x on 1, like write it a little better. And you will need to use factorization a little bit. So those are your 2 hints. Good luck and send your answers on the chat. So that's your 2 hints. X is the same thing as x on 1. You're going to have to cross multiply, but then use your skills to isolate the y. Remember, you want y alone on one side and everyone else on the other side. So you're going to have to use factorization in order to do that. Factorization is a huge topic here, but at the end of the day, the simplest type of factorization is this. Like if you have ax minus bx, anytime you see 2 same letters, factorization means you can extract that same letter and you'll be left with just the a and the b, right? Now, obviously, I can't go through the whole of factorization today. That's something that's take like a whole, like about three 2-hour sessions to go through. But this is the simplest way I could probably say it. Anytime you see 2 similar letters, so if you have km minus k5, because the k and the k are the same, you can pull out the k, and in brackets, you'll be left with the 5 and the m. Right? So that is going to help you. That's going to help you isolate or extract the letter y. Deshaun, check it back. Right, I know you all getting tired, and I can sense it in you all. The amount of answers coming up is less and responses is coming up less. So let me help you out a little bit. X is the same thing as x on 1. So you have y minus 2 divided by y minus 3. Now, remember, cross multiplication can be used when you have exactly 1 fraction on each side. Now, we have 1 fraction here, and we have 1 fraction. This is 1 fraction on the right-hand side because it have 1 divide sign. 1 divide sign means 1 fraction. So let's cross multiply, right? It doesn't matter which diagonal we choose first because both of them have a y. So I'm going to do the solid one first. I'm going to take x and multiply everyone here by the underneath part. Now I'm going to do something wrong, and I want you to tell me what I did wrong. We're going to take x on top here and multiply it by the underneath here. What did I do wrong there? Something is mathematically wrong. What did I forget? Starts with the letter B. Brackets, correct, guys. Remember, I want to multiply the whole underneath by x. When I write it like this, it only means the first letter gets multiplied by x. That's not what I want to do. I have to put this whole thing in brackets. You have to make sure. And then, well, the dashed line is easy. Anything multiplied by 1 is itself. So y minus 2 multiplied by 1 is y minus 2. I'm not going to even bother to put the multiply by 1. That's wasting time. Right. Now, keep in mind, we're trying to make who the subject y. We're trying to get y alone on one side and everyone else on the other side. So we have to isolate the y's. But first, let me multiply out the brackets. Everyone here gets multiplied by x. X multiplied by y is xy. X multiplied by minus 3 is minus 3x. And then you put what? Y minus 2. Now we have a little problem. Remember, we want to isolate the y's, get y's on one side and everyone else on the other side. But we have y's on both sides. So here's what I suggest. Anybody who has a y, well, it doesn't matter if you have something else. Once you have a y attached to you, throw them across on the left-hand side. So remember, this y is really one y, right? He has a y, throw him across. The xy has a y, so he on the correct side. But this minus 3x, he don't have any y's. So throw him across on the other side. Let's see what that will look like. Now remember, when you throw across something, it doesn't matter where it lands. Once it lands on the other side, and you change it and make it the opposite. So you have xy waiting here, doing nothing. And then you had what? The minus 2 over here. These two guys were on the correct side. When you throw across when you throw across positive 1y, you get what? Minus 1y. When you throw across minus 3x, you're going to get positive 3x. You can put the positive sign if you wish. Now remember, you want to isolate the y's. Do you all see an opportunity to factorize here? An xy and 1y have the letter y. So guess what you could do? You could factorize out that y. And you'll be left with what? X minus 1. You'll be left with the x and the minus 1. We almost done, don't worry. We want to make y the subject. Between here and here, there's a secret multiply. So we could take this x minus 1 and throw it across. And when you throw it across, it will become what? A divide. So the whole thing goes underneath. And if you divide it by x minus 1. Remember, when you throw across a multiply, it becomes a divide. And the signs of everything going underneath does not change. That's the end of the question. We have just made y the subject. Y is on one side, everyone else is on the other side. How much of you all are going to get tested on things like this? By the way, I know we're not going to be, I doubt we're going to be able to finish this.